Now we're going to have a closer look to the TCP/IP protocol stack. You remember the implementation of the communication protocols was organized along a layer model. We have discussed such layer model. We have seen that there are different layer models, and the TCP/IP protocol stack follows the TCP/IP model, layer model. TCP/IP layer model, as we discussed already. And when people speak about the internet protocols, they often speak about TCP/IP protocol stack. Stack means that there are many protocols on the different layers, and the internet working is organized by an interaction of all these protocols together. When we have a look to the TCP/IP protocol stack, then we have the upmost layer is the application layer. Here is not the application located. This is what is needed, that an application can use the internet for communication. Then we have the transport layer. Here the TCP protocol is placed. We will discuss this in more detail. Then we have the internet layer. Here the routing is organized and addressing. And then we have the link layer that connects the internet addresses and activities to the activities in the concrete network. And sometimes it is also the so-called hardware layer counted to belong to the TCP/IP protocol stack. You can easily see if people speak of 4 layers, then the hardware layer is not counted. If the people speak of TCP/IP layer model with 5 layers, then they also consider the hardware layer as part of. Each of the involved layers is responsible for solving a special task. This was the idea of this layer model and the implementation of the protocols along such a layer model. In practice, does it mean that each layer contributes some additional information, does some additional tasks exactly to solve the problems that need to be solved on that layer? So it adds own flow and management information to the payload. And in this way, each layer is contributing new administrational data, a new administrational overhead. And here there is a balance needed to add as less information as possible, because at the end, as well, the user data as well as administrational data need to be transported over the internet. On the other side, to add as much administrational data as needed to solve the certain task. Let's have a closer look to the different layers, and let's start now from below. Let's start to consider the hardware layer. This is the lowest layer located below the TCP/IP stack. I already mentioned that sometimes it's not counted to be part of the TCP/IP protocol stack at all. The data transport takes place here in this layer via physical transmission media. For example, an electric cable or an optical fiber, or the air with a radio signal. The determination of the necessary electrical or mechanical or functional parameters for transmission, this is the responsibility of the next layer, and what's done there. So the next layer, this is the link layer. So this is definitely part of the TCP/IP protocol stack. It is also called a network interface or physical layer. Network interface for that reason, because we have the TCP/IP protocol stack that is the layer below of all the separate physical networks, and in a certain point the link layer provides the interconnection of the internet with the physical network technology below. Here this connection provides a connection establishment and determines the convention from the logical interpretation from the bits into the transmitted physical signals. All this is organized and solved on the link layer. The bit stream needs to be grouped into larger logical units, into these packets and into the different parts of the packets. This is organized on the link layer. The data packets, they contain, as I already mentioned, mechanisms for error detection, for error correction. Also, this is organized and solved on the link layer. There are more responsibilities on the link layer, more tasks that need to be solved. The so-called functional separation into areas of responsibility. So we have, on the one side, the media access control. That is also MAC, a control of access to the transmission media. Here we have famous technologies, well-known MAC protocols like Ethernet, like Token Ring, like FDDI. We will discuss this later in more detail. These are the protocols in the physical networks, in the different physical networks, and in the link layer we need to interconnect the internet mechanisms with the mechanisms of the physical network below. Then we have the logical link control, LLC. You see here the link layer is separated by itself in several other layers. Here the management of the logical connection is done, including error analysis and flow control. Then we have the internet layer. And on the internet layer here, the transport service for the data packets is provided, is organized. So that means the path through the different interconnected networks from the sender in one network to the receiver in another network is determined here. There is an addressing scheme provided. The addressing is done here. The internet address, IP address, is part of the internet protocol, is established in this layer. And then is a very important task of routing. That is the transport through the different interconnected networks from the sender to the receiver. And that's not easy. I mentioned already the different networks are usually incompatible. There are different addressing schemes, very different transmission protocols, different packet lengths and other things. So to organize that it's possible to send one packet by means of packets in the different different interconnected networks, this is what is the task of the routing. This means maximum throughput needs to be guaranteed, load cost, uniform load balancing, best possible security, optimal route and other things. This is part of the task that is solved in the internet layer. And the IP protocol, the internet protocol, is the main protocol on the internet layer. We will spend a complete week to understand these mechanisms and the sophisticated way how packets are routed. This is one of the explanation of the success of the internet protocol. Up to the internet layer, we have only organized packet transport service. But the packets are only a part of what we want to transform. We want to transmit complete messages. So on the transport layer, a universal transport service is provided with a kind of guarantee that over the single packets that are transported, the overall message is sent and received by the receiver. So here explicitly switched connections are needed. These are virtual connections which provide the guarantee that the packets arrive and that the packets arrive in the correct order. This is a responsibility that is due to the transport layer, that there are guaranteed quality criteria, including error correcting methods, including the correct arrangement of the transmitted data packets. Reason is here, the data packets can go through the networks along different paths, and so it could be that a later packet arrives earlier. But this makes it difficult to reassemble the packets. So on the transport layer, mechanisms are provided that guarantee that the packets arrive in the correct order. Then in transport layer also mechanisms are provided for data flow control. So to help that the network infrastructure of the different interconnected networks may be utilized in a uniform way, that there is no slaughtering of transmission volume in case of overload, mechanisms to avoid overload, mechanisms to fight against overload. These are all responsibilities on the transport layer. And then the upmost layer is the application layer. Here, functionality is provided so that applications can use the internet for communication. For example, we have a great variety on this application layer, great variety of protocols. An example is the file transfer protocol. Here the protocol is a mean to transport, to exchange a file, to send a file from a sender to a receiver. Or we have the HTTP protocol, the hypertext transfer protocol, to receive a web page from a server in the internet. Or we have the SMTP protocol, which provides a possibility to send emails over the internet. Here is a good example. So the email system itself is not part of the protocol stack, TCP protocol stack. But the protocol that it's needed to transport emails, that is part of the application layer. This makes it possible that the application itself, which does not belong to the TCP IP stack, can use a protocol, can use the internet to exchange, to send emails to another computer by means of connection. Here are more protocols in place. We will discuss the different layers in different weeks of our course, so that at the end of the course you can have a very good understanding of what is the task to be solved, what are the means that are used to provide that functionality, and how do the concrete protocols look like that perform these tasks. To conclude this, the remarks, the application that communicates via internet, the applications themselves, the file transfer, the email, the web browser, they do not belong to the application layer, but are outside of the layer model. And the layer model, this is the communication protocol that's used, that may be used by the application to interchange information.